Well, let's do an example. Let's find the inverse of this elementary matrix. Okay? So we know how to find matrix inverses, and we could do it the old-fashioned way by sticking matrix A here and the identity matrix here, and then row reducing it until we get the left-hand side of the augmented matrix into the identity matrix, and then the right-hand side would be the inverse of the original matrix. Okay, we could do that. But in this case, there might be a faster way here. We know this is an elementary matrix, so it corresponds to an elementary row operation. So let's find that elementary row operation. Okay, so to get from my identity matrix to my elementary matrix, what elementary row operation must I have to do? Remember, an elementary matrix is just, you just apply one elementary row operation to the identity matrix to get your elementary matrix. So if this is truly an elementary matrix, there is exactly one elementary row operation we can do here to get from the identity matrix to my elementary row, matrix here. In this case, it's going to be -2 times row 1 plus row 3 is my new row 3. All right. So now that we have that information, we could think about what would be the inverse elementary row operation. In fact, let me write this on the other side. Let's move it. What would take us back? Okay. Well, to go back, I would need to add 2 times row 1 to row 3. Store it into row 3. That would get me from here back to here. Okay. It is the opposite elementary row operation. And so the elementary matrix corresponding to this inverse elementary row operation will be the inverse of my elementary matrix. And so applying this elementary row operation to the identity matrix, the only change will be to row 3. So 1, 0, 0, 0, 1, 0. And then in row 3, I'm going to get 2, 0, 1. If we apply this elementary row operation to the identity matrix, this is the matrix we get. And so that will be the inverse of my original elementary matrix. Let's confirm. Let's multiply them together and make sure we get the identity matrix. Okay, so I'm going to take E times E inverse, make sure I get the identity matrix when I multiply them. So here's matrix E. Let's take matrix E inverse, 1, 0, 0, 0, 1, 0, 2, 0, 1. And if I multiply them together, row 1, column 1, I get 1. Row 1, column 2, I get 0. Row 1, column 3, I get 0. Row 2, column 1, I get 0. Row 2, column 2, I'll get 1 when I take their dot product. Row 2, column 3, I get 0. Okay, now on to row 3. Row 3, column 1, this is where we have to be a little bit more careful. We get -2 plus 0 plus 2. -2 plus 0 plus 2 is 0. Row 3, column 2, their dot product, we get 0 there. And row 3, column 3, we take the dot product of those, we're going to get 1. Which is the identity matrix. And so we got what we said we would get. We have confirmed the result. This is indeed the inverse of the original elementary matrix.